So yesterday we talked about the standard deviation and how it relates to the normally distributed curve. If it's normal, then it's a bell curve. Only if it's normal. If it's not normal, in other words, if the data isn't normally distributed, where the center is in the middle, the mean's in the middle, and there's even percentage of numbers of both sides. If it's not like that, then we can't use this method. On both sides of the mean, we have standard deviations. One standard deviation, two standard deviations, and three standard deviations. Likewise, going backwards, we have minus one standard deviation, minus two standard deviations, and minus three standard deviations. So if our mean is 50, deviation is 15, as we go to the right, we add 15 to that number. 15 plus 50 is 65. Add 15 more. 65 plus 15 is 80. 80 plus 15 is 95. And going backwards, we subtract. So 50 minus 15 is 35. 35 minus 15 is 20. And 20 minus 15 is 5. So each of those standard deviations represent the amount of data that's within. So within one standard deviation, how much percentage of data is in there? At one standard deviation. See, what I'm saying is, don't waste your time on your cell phones. Review your notes. There's 68% of your data falls within one standard deviation from the mean. Within two standard deviations, 95% of your data falls within there. And within three standard deviations, we have 99.7. Now, instead of having to read those off a sheet I gave you or look at your notes, you should have those in your head by reviewing your notes once in a while. I'm trying to help you all in your future endeavors. Because after you leave this school, you go to university, good luck, because they won't give you so much pampering. They're going to expect you to know this stuff and just keep on talking. Questions won't even exist. You won't have time to ask questions. So I'm trying to help y'all. Get your studying habits down. Get your cell phones away from your desk. Don't have it anywhere near you when you're at school. It's just going to waste your life. But that only works. This only works if we know our first, second, third standard deviations. What percentage of the data if I had 30? So how much percent of the data is from 30 to 50? How much of the data is 97 from 50 to 97? All these other things. Now, this is what we're going to learn in this chapter, in this section. If the value is not at plus or minus one standard deviation, plus or minus two standard deviation, or plus or minus three standard deviation, then to find, bless you, the percent of data from that point, you need to use the z-score method. They thought about that because remember I said earlier, the more data you have, the more accurate you have. Well, the same thing comes with this. We use z-score for large data sets. If it's a small data set, less than 20 25. Then we use another method called t-scores. We'll talk about that later in the semester. But for right now, we're going to discuss the z-score. The formulas for sample and population, again, are different because, remember, in samples, we use our alphabetic. In population, we use the Greek letters. So the z-score for a sample, it's x minus x bar over s. And the z-score for the population, x minus mu over rho. And since I know you all spend your time reviewing your notes, I won't have to go through what those letters mean. And once we determine what the z value is, we have to look up on the table, see exactly what the table will tell us the percent of data from that point. But we first have to convert it from our mean and deviation to our z-scores. And remember, we talked about yesterday about significantly high and significantly low values. When is it significantly high? Which one? Third? No. Put your notes again. If it's greater than 2 standard deviations. It's significantly low if it's lower than your -2 standard deviations. So anything on the outsides, that will determine whether it's significantly high or significantly low. What do you call the stuff in between? Not significant.
Not significant.
Because the closer you get to 0, the less formative that information becomes. It doesn't tell us much. Okay, now we have to figure out something else, because we're going to look at the sample formulas. The z-score, the value you get for the z-score, if it's negative, if it's less than 0, if it's negative, that means your x value that you're looking at is to the left of the mean. If your z-score is positive, then your x value is to the right of the mean. That should just be one of those no joke. Why is that the case? Why is the z-score negative if it's to the left?
Because left is significantly low.
What's that?
Because left is significantly low.
You can't use the word significant there. We said we have as a negative because if our mean is here and we pick an X value here, say the mean is 50, and we pick a number that's 40, look at the formula. The formula is X minus X bar. So since the X is lower than the mean, we'll get 40 minus 50 over whatever our standard deviation is. So of course, it's going to give us a negative number. Because it's to the left. The number we're looking at, the value is less than the mean. If it's greater than the mean, 70 minus 50 is going to stay positive. The deviation can never be negative. Why can the deviation never be negative? What's the formula? What's the formula for deviation?
S square root. So
Because there's nothing in there that can make it negative. No matter what's inside here, when you square it, it becomes positive. When you add a bunch of positive, it's positive. N cannot be negative. It's a counter, it's a number. And you can't ever take a square root of a negative number. So S is always positive. So our Z-score, the only way it can be negative is if X is to the left of the mean. All right, let's look at these. Example 1. Which of the following two data values is more extreme relative to the data set? Okay, here's A. It says the 99-degree temperature of an adult among 106 adults with a sample mean and sample deviation.
please, sir, can you put your hand down a little bit for me?
I'm sorry, it's louder, I can hear you.
Please, can you bring the paper down a little bit?
Well, yeah, so I'm gonna do that in a second. I have to verify these numbers first because it's missing something.
Sorry, Professor Migala, I just got on. What section are you on?
Chapter 3, Section 3.
Thank you.
You're welcome.